Hello everyone! In this video, we'll continue with dissecting the Metasploit download exec payload. Remember that the payload was generated using this command, which specified an exe name and a URL. Then, the output payload was this one, which we tested on a Windows 8.1 machine. The goal of this video is to understand the default Metasploit obfuscations. We'll study junk code, control flow obfuscations, anti-decompilation, function calling tricks, and function resolution techniques. In the following parts, we'll also deep dive into assembly code part of the shellcode. So let's begin and open the file in IDA-Pro. Notice that it contains the name of a PDB file. Not really relevant for us, since we don't have the PDB file anyway. This is probably just for decoy, just a lure. Notice the start function was recognized by IDA. This is where we begin. And if we look at the code here in the graph overview, notice that the function is actually pretty huge. Let's have a look at its code. Straight away, notice a lot of junk code. Switch using space from graph view to code. Look closely and notice that it starts with a lot of meaningless instructions. And sadly, these are not only at the beginning of the code. There are junk instructions everywhere. There are junk blocks preceded by a jump. More junk code here as well. The jump goes to another jump which executes something, then goes to another jump. Then calls another function and so on. So the first trick is the abundance of junk code. Okay, just scroll around a bit and you'll notice that the flow goes from instruction to instruction by using jumps. A lot of them. Few instructions are executed and followed by a jump with a block of junk code in between. So we've seen this one. Code flow obfuscation is performed using these jump tricks, but also using another very interesting technique. Go back to the start function. Notice that if we take the first jump, there is a call here. There is a call to a function. Let's rename it function 1 so we can follow what's happening. If we go to function 1, again the same trick, a jump followed by junk code. But then notice the first instruction here is a pop EBP, which basically pops into EBP the address that was pushed on the stack by the previous call instruction. And this EBP address is actually called later on. It might sound a bit tricky at first, but to understand what is in EBP, we need to go back to the call and remember that when we call a function, the address of the next instruction is pushed on the stack. That's so the function knows where to return. So this call here automatically puts this address on the stack. And when inside function 1 we execute pop EBP, that address from before will be placed into EBP. It will then be called later. This is a pretty neat technique to call functions without properly defining them. This contributes to the overall code obfuscation. It means that the code starting from here, from this jump, is actually another function which is popped into EBP to be executed. Another function starts here. Very interesting. We will see in the next videos what this function does, but that's a pretty interesting technique to call functions. So we've seen junk code, we've seen code flow obfuscations. Anti-decompilation is achieved by default here because the code is so convoluted. It's almost impossible to create proper functions instead. We don't have any function prologue and there are no calls to this address explicitly. Even if we used a tool like hex-race decompiler, it still couldn't disentangle the code. We're stuck with manual analysis. Another trick that prevents function creation is the presence of jumps and junk in between. Let's say, for example, we try to create a function out of this code. We would go to Edit and then Functions, Create Function. Notice it is actually disabled. We cannot do it. And it's the same for the other parts of this code. This part of the code has been written in low-level assembly language. And it was written in such a way that it prevents us to understand the flow without looking at minute details. Function calling tricks. There is this one we've seen here, which puts this address on the stack and then calls it. But there are a few others as well, which we'll see in the next videos. One last thing to note is that the functions used by the shellcode are resolved dynamically. Although, if we go to imports, we see a lot of functions imported, including network-related functions. We know our shellcode performs a download. Let's try to cross-reference one function. For example, connect. There are no references to it anywhere in this code. We'll see in the next videos how functions are resolved dynamically by the portion of the code that starts here. Another very cool trick. Remember that this Metasploit payload was generated using no options for the encoder, so the default encoder Shikata Ganai was probably applied, which is pretty cool. Let's recap. In this part, we've seen junk code and control flow obfuscations. We've seen anti-decompilation tricks. We've seen a very interesting function calling technique. And, although we haven't explained it yet, we discussed function resolution. In the next video, we'll deep dive into the shellcode that resolves functions and calls them dynamically. Thank you very much for watching, and please let me know your opinion in the comments. See you in the next video. Cheers!